Alright, let's get started with today's lecture. So, what we have been doing is we'll take a look at a few examples today from chapter 4. So, given R is equal to,
Is this from last class?
right, it's a little before last class, but it's same chapter. It's all coordinate transformation. So, you're given this, and you have to find right ascension and declination. Okay. So how do you go about right ascension and declination? So that our angles are these angles alpha and delta. We did this some time ago.
What is DEC?
Hmm?
Definition.
Solution would be you compute R, which is equal to, how do you compute R? Magnitude, right. So you just have to do this 3000 square plus 6000 square plus 9000. This is the first step. And then you have compute the direction cosine. L is equal to x over r. N is equal to y over r. And n is equal to z over. So what is this value? Can somebody tell me what is this value? Calculators? $11,225. 225. So your L would be simply minus 3,000 divided by 11,225. And what is this? Huh?
Minus 0.267.
Minus 0.267. And what is M?
And it is
Minus 6,000 divided by R.
minus 0.534.
53?
Yeah.
4?
Yes.
And N is minus.
Minus 0.802.
This is how you compute. Then you have compute the declination delta. Delta here is sine inverse n. So can you tell me what is sine inverse n?
Minus 53.3.
Minus 53.3 degrees, or this is equal to 3, 0, 4.7. And then finally, to compute alpha is equal to the here it is 360 minus cosine inverse 1 over cosine. Tell me what is this? So what is cosine of this?
0.569. Cosine. So 3.
Hmm? Say it again. Domain error. What is the angle? Really? You're not able to calculate the angle?
The cosine. I got
Huh?
for 1 over cosine of
Hmm.
delta
Hmm.
is 1.76.
Okay. So what is cosine inverse of 1.76?
So what?
Cosine inverse of 1.76. What is it? Hmm. Huh?
It's undefined.
Huh? Hyperbole. Where is hyperbole? Okay. What value did you get here?
Where Just for cosine delta or one over cosine?
1 over cosine delta.
Just 1.76.
So what is cosine inverse of 1.76? Undefined?
You said the sine inverse?
Cosine inverse. Huh? It's a domain error.
For the sine?
Is this correct? Check for this. Cosine 53.3. Is it the same as this? Should be the same.
Minus 32. Sine, inverse sine.
It's supposed to be 306.
306.5. You are right.
It's still a domain. It's still a hidden.
Yeah.
So what is the range of cosine?
You say the range?
Yeah. Anybody?
0 to 1.
What about that?
0 to 1?
80.
Huh? No, range of cosine. It cannot be 180. What is the range of cosine? What is the range of sine? What is the maximum value of sine? What is the minimum value of sine? So the range is negative 1 to 1. So what is the range of cosine? Huh? It is negative 1 to 1. Right? So what I am getting here, it is out of range. Is it out of range? What do you do? It is out of range. You understand what is happening? The range of sine is, huh? Is this an angle or is this a value? What do you get here inside this? You get a value, right? So this is going out of range. So figure out what do we do when it goes out of range. Okay? But this is how you go about computing the right ascension and declination. Alright, so let's take a look at another example. You're given R is equal to minus 6600. Now what you need to do is, I think let's look at this. Let's say you're given this minus 1303 minus 5200 and E
Is that 5,000?
6,600. This is 5,200.
But that's 582.
This is 6,600. This is 5,200. And E is minus 0.4i plus 0.5K minus 0.3K. Given these two values, and you're told, or you're asked to evaluate the inclination, find I. So how do you go about finding I? Now tell me what I is. What is the definition of I? I is cosine inverse. It's the angle between H and the right CM. So here you can say it is. See, these things, if you understand what the angle is, you don't have to remember the formula. You can just derive the formula. So here you can say I is cosine inverse H dotted with K divided by H.
Okay, so is this page 194 in the book?
The problem is 233. The problems are in 233, page number 233. Okay. Now, what is K? What is this K? See, you're given R and E in these vectors, right? So what is this K? So this is what you need to know, or you need to know how to write this. So you're going to sit there and wonder what is this K? This is this K. Compare these and these. Okay. How do you calculate H? From the given values, how do you calculate H? You're given R and E. There's no V. You need the vector H and you need the vector. Vector K is this. Okay. If you know the vector, you'll know this. So what is that vector?
So H is our, you have to do a cross product.
What cross product are you doing?
Cross product of R.
So if you look at this problem, this is problem number 4.7. What algorithm am I going to use? You will need to use, so we have discussed this, to figure out how to find the various orbital elements, you will need V here. Do you need V, or you can do without V? Yes, Adam.
So for H, will we use that mu A equation?
Mu A.
It's like mu times A multiplied by 1 minus E squared under the square root.
That is this H. Now you have to please look at. It will give you this H. Will it give you the vector? And you don't have A there, right? Let's look at a more straightforward problem. Okay. So let's say you're given R and you're given V. V is 6I minus 7J and E is given to be 4.5.
So what were we supposed to do to find V?
Actually, that's a wrongly stated problem in the text. What they did was, if you look at the previous version, they have mixed up problems 4.6 and 4.7. They expect you to use the information from 4.6 to figure out 4.7. So it should be this. Now tell me, how do you go about finding the calculate the true anomaly? How do you find the true anomaly? So here, if you are required to find the true anomaly and the inclination, how do you go about doing that?
So theta is equal to cosine inverse r dot e over r.
Right. So here it is very simple. The true anomaly is really simple. What from the previous listing we could have found the true anomaly. Theta is simply, what do you know about theta? Theta is the angle between.
The orbit and carriage.
So what vectors is it? Theta is always the angle between r dot e. Okay. R dot e is what? R e cosine theta. Okay. So here theta is simply cosine inverse r dot e divided by r. Now tell me, this is the first one. Second one is inclination. How do you find the inclination?
Cosine inverse of r dot e to h.
Right. So here, if you look at this inclination, again, inclination is simply h dotted with k is equal to started with K is simply H Z or HK. You agree? So your cosine I would simply be cosine inverse HZ. Okay. What is HZ? But we don't know H, right?
So V dot H, V dot, oh, you do know K, K is 0, 0, 1.
What is H?
You can do V dot K, right? I mean,
H is R cross B.
R
oh,
cross
okay.
B. So here you don't need to save, yeah, so you can do R, H is R cross B.
Okay.
So you get, you figure out this and
Take it back.
then it will be, you can calculate this. What you're going to get is, one of you wants to do this? Minus 1, 2, 1, 2, 5. Alright, just compute this. So what you're going to get here is H X I plus H Y J plus H Z. You have to take the value of what is this H? So this will
So
be
magnitude.
this here, HC. The component here will be HC, and H will simply be square root of HX square.
So you just take HZ
Right.
at the top instead of the whole thing?
Yes.
Why you did that? Only because if you crossed it with,
Huh?
why did you do that? Because if you crossed it with 0, 0, 1, you get the same thing?
This one,
Yeah. If you did it without,
I crossed this one. What you're going to get is you're going to get this. If you do a cross product on that one, you're going to get this.
right, and you say only use the HZ.
That's what you need, right?
And I'm saying only because if you cross that H that you just found with K, you will get the same.
You don't
number.
cross, you dot.
I mean, if you would dot that,
Right, of course.
you get the
So
same.
what is this K? Again, remember what is this K?
0, 0, 1.
0, 0, 1.
So
Right?
it's
So it will
dot.
be HX into
Oh,
0,
okay, that's
HY
fine.
into 0, HZ
Yeah.
into 1.
Okay, that's what I was.
So this, now the trick is, or this thing is, what you need to figure out is, this theta is, you're going to get two theta values. You realize that? Are you going to get two theta values for this?
You say 2 data values?
Right.
Why?
Why?
Oh, because of the little thing that we went on, the degree can be the same. It's different.
So here, you have to understand, cosine of theta is also equal to cosine of negative theta, right? So this could be theta or negative theta. Okay. And you need
But
to,
if you plug in the right data,
you cannot plug in the,
but no, if you plug in,
you're going to get this, whatever value you're getting here, whether you plug in cosine of theta or cosine of negative theta, you're going to still get that back. You understand? So this theta is always here again. You're going to face the same problem. This I, you're going to get two values. Okay? How do you resolve those? And you've discussed this in class.
Because I is from 0 to 180. I is from 0 to 180.
0 to 180.
Yeah.
You sure?
You said that was the range.
So it again, it depends on, if you're looking at 0 to 180, if you change the direction,
You're gonna look for this way.
then it changes, the angle changes. So this is very, very nicely captured in that algorithm. You can look at algorithm 4.2. Okay. And we'll explain to you why is that the case. Now, so we can stop here. You guys have a, I'll send you up an assignment today, and you can prepare accordingly. Your, this will be a closed book, okay, no open book, and you don't really need to, yes, it will be a closed book, okay.
You say what?
Huh?
You say what?
It will be a closed book. This you don't need any.
What about a formula sheet?
You don't really need formula sheet either.
Yeah, next week.
Huh?
Next week.
It is next week.
It's Wednesday.
Huh? It is the following Wednesday. Next Wednesday. It's not following Wednesday. It's Wednesday. Because yes.
How does the exam for this class work? Like what period will this exam be during? Will I apply to this class?
What period?
Oh yeah, you say you're gonna discuss that. Because we take the class on Tuesdays, but the original time was at 10. So,
Oh, the final exam. You mean?
yeah.
I think we'll go by Tuesday.
Okay.
So that's the major thing.
Tuesday, 8 o'clock in the morning.
That's going to be Friday, the 9th at 8 or at 10.
What is the question?
They actually
This one is This one is
Oh, you excited?
Any questions so far?